Welcome everyone. Uh, Thanks for joining us for another edition of our journey into the ESTeem Software Suite. This is a whole webinar series that we're doing, kind of going into detail of our whole utility suite used to basically have interfaces directly into the radios. Today we're actually going to be looking into the 195 narrowband configuration utility. So as we kind of move forward, to kind of give you just a little brief history of where did this come from is ESTeem itself. We're focused on kind of the major markets that we really kind of play into the heavy industries. So we get into the water, wastewater, oil and gas, mining, dredging, material handling, power and energy, agriculture, and especially a lot of these applications is probably one of the biggest successes and predominant player within this is our ESTeem 195 narrowband. This is a licensed radio, so it's an FCC licensed narrowband radio, which is it basically is kind of there as the name implies. And so this one you actually obtain your exclusive use of that frequency, so you're only one on there. But it is a narrow band, and so it's a very small channel, but it still has some very specific use cases to this, and these are some things that is highly sought after and very unique about this radio. As we kind of look at this, one of the things is as we started going through this is we wanted to provide a much more visual way of interacting with the radio. So we came up with an entire software suite. And really what this is a whole family of software utilities that we use for programming, configuration, monitoring, and troubleshooting for the different radios. This is software that we developed and have just released. It is available up on our website under the Resource Center. You'll see an ESTeem Utilities that you can select. Takes you there, and it's a free download. There is no cost for this, and so it's something that not only gives you the ability to configure, but also some very powerful tools to go through that. As I mentioned earlier, what we're concentrating on today, or where we're focusing, is really doing a much deeper dive into the 195 narrowband configuration utility. And kind of what we're going to go through today is what does this actually give you? Well, this is basically how we configure each of those radios. This is how we set up whether you're going to be a serial communication network, if it's going to be an Ethernet IP network, and the settings for that. How do we set up the routing to go through particular repeaters in order to get to a destination? And this is done a little bit differently whether we're talking about serial operation or on the Ethernet IP operation. One of the other things that differentiate ESTeem is that we are very, very aware of backwards compatibility. So this 195 narrowband radio can actually be backwards compatible or downwards compatible to our previous generation, which was called a 192. And so there's actually a way of setting this up for that compatibility. We want to provide the tools. This is where we can update firmware. We can save and load configurations, say backup files. There's a console that can be launched directly from this utility. We can do Modbus monitoring. There's a spectrum analyzer built into this thing. It really is a full product that gives you an abundance of tools in order to communicate as well as set these things up. Also, we want to give the diagnostics. So this is where we can actually transfer data between radios. We can verify the connection status. We can see how many retries are out there or what we're looking at, what kind of RSSI or signal strength from both the local as well as what the remote is seeing. So this is kind of what the whole idea of this tool is. I'm going to go ahead and turn this over to Eric, who's kind of our resident wireless guru. And he's going to walk you through exactly how this tool works and kind of give a tutorial and really kind of do a live demonstration of this. So with that, I will turn this over to Eric, and he can dazzle you and show you exactly what this can do.
All right. Thanks, Dan. I appreciate that. I'm kind of excited. We're going into quite a bit deeper dive now into our utilities and how each of these is actually used in conjunction with the individual radios themselves. Um, One of the things is, as you've mentioned here, this is kind of a continuation on the series of radio tools that we've put out, software utilities. And the one that we usually start with for just about any of our radios, which allows us to change the IP address to match of the radio to match into the computer or the network subnet is the Esteem Discovery utility. Now, the Esteem Discovery actually has quite a bit of uh, unique tools in itself, and we covered quite a few of those in our very first introduction of this. But it is also kind of the launching point for a lot of our other programming software, the 195 Narrowband configuration utility being one of them. For example, you can actually start that utility by pressing the Start button, going into the software suite, and you can see the narrowband configuration utility can be launched directly from here. But in most cases, it's much simpler to press Discover, find the radio itself. As you see here, this is an Esteem Model 195M, one of our VHF radios. And what it will do is it will automatically link and open up the programming utility to the IP address that is actually listed for that particular radio. Purpose being that you can, if it is at a completely different utility, say you're using a Class C network with a 192, 168 address, you could actually adjust the radio so that you can open it up and verify that you are talking to it. So from here, what we want to do is to open that narrowband configuration utility. You can just simply do a right mouse click on the radio itself. And if you hit the button that says configure radio, what it will do is it will link to the radio, and you can see there's the IP address of the radio itself. Down here at the bottom, it says status read configuration is done, which means that it is actually linked to that specific radio. Now, this tool actually has many different looks that it will have based upon the radio itself. What I mean by that is that the configuration tools that you'll see here really depend upon the radio um, version or the model number. This specific one, the 195M, it has not only the compatibility, downward compatibility to the previous 192M and 192M HP radios, as Dan had mentioned, but it also has a very specific channels that can operate. There is there are specific frequency channels available, 5 different channels within this particular band that can be utilized for unlicensed operation, even though it's in a licensed radio frequency band. So the reason I'm pointing this out is that if you were to open up some of the other radios, the 185H, which is a 217 megahertz radio, that particular one never had a previous generation of it. So the only thing that you'll see listed here is the general and the routing. Or if you're in the UHF version, you'll only see general routing and 192 compatibility. The MERS frequency band tab will not be listed. So it's no reason to panic. It just the utility will find out and only show you the parameters that are for that specific radio. Now, what we've tried to do, we've tried to break this down into two main categories. The first one is the configuration parameters, which is where you're going to come up with a configuration per a basically a configuration file for that specific radio, and then write that configuration file to the radio. Or under the Tools tab is a lot more of the programming features, like you can save the configuration utility and write the configuration utility. You can also go in there and open the console, Modbus Analyzer, and we'll get to each one of these as we go through it. Just kind of want to give a quick tour of what we're looking at here on the main screen. The next one is you'll also notice that we have both a local IP address and a remote. So what this utility allows you to do is not only look at, verify, read the configuration, and write the configuration. You can also do that for a remote radio within the network once the radios are programmed. Now, the reason that you do this at a later time is that you need to verify that all the radios are set at the right frequency, they are at the address you expect them to be, and then once that's done, you can actually get out there and perform these remote functions to it. So let's go ahead and take a quick look at how this is actually laid out. Now, under this configuration tab, under the general configuration, there are actually two different modes. There is the basic mode, which we currently are viewing here, which you notice is a very simplified interface into the radio. We can also look at the advanced tab. which lists all the configuration parameters for the radio. So if you know if once you become familiar with it, you only want to adjust specific elements to it or adjust more advanced features like the power level in the radio, this is where you'd go to the advanced. In most cases, you're actually going to be using the basic configuration because it's only going to ask you or have you set those very specific parameters that are necessary for the type of application you're going to be using the radio in. Let me give you an example. Everything starts with the data interface. We need to know where the data is going to be coming into this radio. As Dan mentioned, this is a very powerful radio. It works like I consider it really kind of our Swiss Army knife. It does a little bit of everything. So it can actually do different types of serial information. RS-232, RS-422, RS-485. We can also use the Ethernet port to send the data. And each one of those, as you'll see, is actually listed here within our data interface. And the reason I want to make a point of this is depending upon which interface you select, it's going to ask you different questions. So if we set this up for RS-232, it's not going to really care about the IP address any longer. What it's going to be doing is using the last octet in the IP address as a single node address because serial does not use IP addressing. So it will actually conform to the type of network you're using. So if we're going in and saying we're going to set this either to a PLC, we're going to configure it into a legacy PLC that is running Rockwell's DF1 or Modbus RTU or ASCII or Opto22, then what we will start with is setting the data interface. We're going to match the address to the radio. You set the frequency. The radio itself can use any one of the remote radios within the network as a repeater. So you can actually then put in the repeater address. So if we put in repeater number 1, then we could actually say it's going to go through address 10 to get to a destination. Well, that destination can be a broadcast, as we have listed here, or it can be a very specific radio. Say this is actually going out to, and we're going to send all this information to a destination of 25. Well, a lot of these parameters really come down to what mode or how we want the radio to uh, act. In a lot of cases, we've written the protocol emulations for most of the major PLCs out there. So the destination does not become as critical, and I'll show you what I mean by that. So if we go past this first page where we've set the address, set the frequency, we're not going to worry about the repeater to begin with. If you go to next, it's going to ask you what is the serial data rate. So let's say it's running at 19.2, 8 data bits, 1 stop bit, no parity. Okay, that sounds good. We hit
Hey, Eric.
next. Yes.
So on that last screen there, so when we're setting that, is that to match to what the connected device is spitting data out at? Is that what, how do you determine what that should be?
That's a great question. And actually that is correct. What we're doing is we're matching the serial port on the radio to the connected device to it. The beautiful part is that the
Okay.
radio is independent to the device it's connected to. So you could actually have one PLC set to 19.2 and the opposite set to 9600. It's only going to be determined by that specific radio we're connecting to, or excuse me, that connected PLC, RTU serial device we're connected to. So
Okay.
what we're going to do, so we match this up to say 19.2, 8 data bits, that whatever parameter we need to be set to, hit next. And then from there, it's going to ask us what type of protocol are we going to be sending it across. Transparent, pretty self-explanatory. Whatever the radio receives, it's going to take this information in and send it to the address that we have set here in our destination. If we want it to go to everybody, then we can leave it at the broadcast address. If you want it to go to one specific radio, then you set the destination to who it's going to be. In most cases, though, we are putting this into a control application and we're going to select a specific type of protocol. we're going into. Now, the reason that we do this is we've done a lot of work. We've been partnered with a lot of these different PLC manufacturers over time. We're still a partner with Rockwell, and so we can actually support their DF1 protocols. Now, we can do full duplex, half duplex, radio modem protocol in either BCC or CRC. And again, what we're doing is we're matching the connected interface. So if the PLC is configured for a full duplex CRC, then we'll put the radio to a full duplex CRC so that it matches into that device. And why this is important is that um, if we have an emulation driver specifically written for the PLC, say for the Allen Bradley DF1 Modbus Opto22, the radio will automatically adjust, will find the destination address and make that our own destination address as we send it out to those remote sites. This is kind of, we can get into a lot more of the details of it. This is kind of outside of the scope of what we do as far as the configuration utility. But really, what you're doing is each one of these um, compatibilities or different protocols, we've actually written an engineering report on how that is actually done within in much more detail. So what I wanted to do is kind of show you the parameters that have to be set in each one of these. So if we go and say we're going the Allen Bradley DF1 CRC, the next thing it's going to ask us is how many different retries do we want to send on the wireless link? And a lot of cases, so for example, if we go back to the full duplex, the PLC is actually doing the retry, so we have ours set to 0. If we actually go into, say, the radio modem, you'll notice that the retries are now being done by the radio, so they'll be set to 6. Most of the time, you're not going to have to make an adjustment to these parameters, but these allow you to actually adjust. So if you're in a very noisy environment, you may find that you need to add a few more retries to the network so that it can actually get the data through reliably. We can also encrypt the data at this point by setting the wireless encryption and setting the passphrase. This will set it to an AES 128 level of encryption. Once we have established that, then we can just simply write that configuration to the radio. Now, as you'll notice here, what it'll do is it'll take about 6 seconds for the radio to reboot. And once it comes back, it'll actually reread the information. So if we hit read configuration, you'll see here that it lists those parameters. And as we go through here, you'll see that it actually changed it and saved it to that CRC. Now, the only thing that's any different when we go to an Ethernet interface is we do not need to know specifically what the protocol is for that. We just need to know the address, the frequency, and whether or not we're going to be encrypted. But we do have a couple different ways of helping limit how much traffic goes across that interface. The first one is if you use the Keep Alive, TCPI Keep Alive proxy, every time that the radio sees a Keep Alive address and recognize it where it goes to, it doesn't have to keep sending that Keep Alive packet to the same remote. It'll actually proxy it. It'll do it locally. Same thing for an ARP or an address resolution protocol packet. Once we've established where these devices are, we can turn the proxy on and greatly limit the amount of throughput to it. But as you notice here, those are the only two questions that it asks us as far as the Ethernet interface. Where this is all really boiling to is that once we've established the basic programming parameters, we then need to go into the routing tab. Because the routing tab is going to tell the radio, if I see a specific destination or address, how do I get that data there? So the routing information is actually fairly simple in the radio. It'll tell us, okay, if I see this as a destination, what address or remote address does it actually go through? So if I actually put in, let's say we're talking to a remote address of 25, and the IP addresses that it's going to support are addresses 30 through 35, it'll automatically create next route. It'll automatically create that entry in the routing tab. Now, the reason that this is very important is because from the narrowband, it is a very, very limited throughput compared to a lot of our other Ethernet-based radios. And from that, we are almost building a router backwards. You need to specifically put in and tell that radio what are the remote addresses it's going to be talking to.
Okay.
So This configuration tab just kind of makes it a little bit simpler so that you can go in and do this. You can also switch to the advanced, and once you become familiar with it, you can actually just directly enter in the start, the end tab, and the destination for each one of the within the radio. Once you get a little bit familiar with it, this is actually going to be the tab that you're going to be going through. But as you'll notice, there are quite a few different routing and repeater capabilities within this. Now, the only thing that changes in this, if we go back to the general tab and we were to set this radio for serial data, let me go ahead and set it up for there real quick and write that. Okay. Now, once we go into the routing tab, what it does is it basically changes the questions that it asks you. It's not going to ask you a group of IP addresses. It's going to say, okay, if I am going through one up to three different repeaters, what addresses am I going to serve? In other words, that repeater, say we've got an address repeater of 10, and it's going to, off of address 10, it's going to do addresses 20, 21, 22. We can just simply say the start address is 20, the stop address is 22. We go to the next route, and that is all that's necessary. So we can create these larger complex networks. As I mentioned to you, I want to give you an idea of how this is entered inside of this utility. How this is actually done on a much greater detail is usually found within the user's manual and the engineering reports that we have set up for each one of those. Again, if we look at the advanced tab, it's just going to look a little bit different because this allows us to do what's called grouping. In other words, if we are connected on, say, an RS-45 network, and we've got 5 remotes that we're talking to, we can group all of those 5 into one single radio. So as you're seeing, this is a very, very powerful and multi-level configuration device. So this is going to be a little bit more complicated as far as the configuration on how it's laid into the overall network, and we'll be happy to help you walk through this. But the tool will help tremendously, and once you get that down. Once we go past the general and the routing, if you do have compatibility to the 192, it's very simple. You just tell this radio, yes, I'm going to be talking to an older model 192 network, and which address am I going to be talking to? Because the radio needs to learn the generation of the 192 was almost 20 years. So it goes out and finds out what levels do I need to set within this model 195 to talk to the model 192. And to do that is what's called training. Okay, so you put in the address it's talking to, you hit train to remote, and it will automatically set it up so that it can go into that older 192 network. The 195M is a little bit different because as you notice on here, if you are actually going to be using it for MERS, what you can do is you can set, I want to use the MERS mode and I want to use a specific channel. These are nice because what it'll do is it'll allow you to operate these narrowband, um, very, very difficult terrain capabilities without having to have an FCC license. Again, that's only available on the 185M radio. There are some very specific limitations. You can go no more than 20 feet above a structure, and we're limited to 2 watts, and no repeaters are allowed. But as long as you follow those capabilities, you can utilize that, especially within 185M. So that kind of covers a lot of the configuration side of the radio. Now, once the radios are configured, now we can start utilizing some of the tools within there to see how well they're actually operating. So if we click over to the tools, you see here there's really 2 different tool tabs, the miscellaneous tools and the diagnostics. Well, the miscellaneous tools, what it allows you to do is it allows you to update the firmware. Now, anybody that has used our 195 narrowband configuration utility in the past, the firmware has actually been pulled out of the utility so that we can do a completely independent firmware update with a separate utility found on our website. Now, As I mentioned to you before, we've done a lot of reading and writing to a particular radio. But if we want to save a configuration for a radio for historical sake or to save it to replace in a spare radio, this is where you'd go in, you would save the configuration file from a radio and allow you to also load the configuration or a saved configuration file into a different radio. Now, the console, those of us that have used the 195 and the 192s for many years, this just gives us a direct interface into the radio. Now it actually opened over here. You'll notice on here, we actually have direct access into the radio. So you can actually go in, if you know all the software commands into it, it's just a quicker way of doing it. It also gives us some of the core troubleshooting to allow us to do packet monitoring, packet dumping, these parameters, which may come up when we're doing some troubleshooting to it. We also have the ability to use or look at the Modbus information from the radio. So we actually have a Modbus monitoring tab. Now, as you'll notice up here, the radios, as I mentioned to you, it's kind of a universal tool. So these actually have 4 to 20 milliamp sensors built within them. So you can actually put a 4 to 20 milliamp input into the radio, and it will show you what the actual channel is. And you can do this from a remote location also. So it's going to give you everything from the core temperature, input voltage, all the parameters within that radio. This can either be read from a Modbus reader, or we can bring it up as far as a utility, just a simple Modbus monitoring. In much the same way, the radio can be put into a spectrum analyzer mode. If you use the spectrum analyzer, what it will do is I'm going to push the analyzer. It opens up the spectrum analyzer tab. You set in there what frequency you want to monitor. Let's say we want to check 165 megahertz, and then we can enable the sweep. And that center channel in here will actually look at 165. It's a very, very powerful tool. There is not a great resolution on this, but it will, in most cases, tell you if you are receiving outside interference or you're picking up a bunch of background noise. At least you've got the capability of monitoring that without having to have an outside spectrum analyzer. It's an incredibly powerful tool. Beyond that, the last tab that we're going to take a look at is this diagnostics tab. Well, as you can see, the radios themselves, depending upon the mode of operation they go into, you can't necessarily rely on, say, an Ethernet testing, to like an IP ping test. That will only really work well if the radios are in Ethernet mode. If they're in a serial mode, we have to have a method of determining how well they're actually operating. Now, that's really where this diagnostics tab. What you can do is you simply add in the remotes, radios that you want to be talking to. If they're going through X number of repeaters, you can put that information in there. You can add this information into the test and run your test. Now, this test, what it will do is it can run for as long as you operate the utility. It'll tell you the connected status, how many retries it's taken, how many iterations, and overall the percentage and how much data is being sent across there. Another key powerful thing that it's doing is it's reading the Modbus information, and it can tell you both the local received signal strength, in other words, how much the local radio is receiving, and read that information in this specialized test packet. You can actually read it from the remote radio. I've only have one connected to our network here, but you can see where this would be an incredibly powerful tool. And the reason that we put this diagnostic utility in is if you are running into a serial application, this is really the only way to tell how efficient the radios are operating in that environment. So as you can see, there's a lot of different capabilities within this narrowband configuration. It is a little bit more adjustable, let's say, from some of our other radios because it can do both serial and many different applications or many different interfaces and Ethernet bridging. But you do need to specify in there how it goes. So overall, the utility itself is fairly easy once you get in and start working with the different parameters. Was there any questions that you that came up, Dan?
No, no, other than just the one that you already addressed earlier.
Okay.
And and I guess one thing to add there that is, if you go back onto that MERS tab,
Yes.
one of the things there that I think for people to understand it is it does have some different regulations to that, such as the how much power it can put out. When you actually put this into the MERS band, it's actually doing this already. So it is going to limit that to the 2 watts, and it won't allow you to put repeaters in there. So it is something that when you select this, it kind of dummy proofs it.
Great. That's a great way to put it. Yeah, because if I write it into a MERS channel, then if you go back into the general and go to the advanced tab, you can't adjust it up. You can't
Correct.
adjust it greater than 2 watts, and you can only set specific frequencies. Thank you for pointing that out. That's a great way to look at it. All right. If anybody's got any questions about the narrowband configuration utility, please let us know. But we would be happy to walk you through this. And I want to appreciate and I thank everybody's time today in going through this utility.
Thanks, everyone.
Thank you.